with a larger firm, or possibly someone that's outside and works on projects in New York City, you will know that New York City have their own specific gauge requirements for kitchen exhaust. So there are a few things in the New York City code that differ from the IMC, but also from NFPA 6. Add Bianca in here. Hello, Bianca. So NFPA 96 is really your base standard for kitchen exhaust systems, which very closely matches the IMC Uniform Mechanical Code, depending on what territory you're working out of or what codes you are tying into. And then, used as a basis to tie into each regional code requirements. So in New York City, we do have a specific gauge requirement. So this is for welding duct in the field. So you're going to have a minimum of 16 gauge, and then as the duct gets larger, you'll step up 14, 12, 10 gauge. And the exception to this is listed to UL 1978. For us at Durasystems, we have 16 gauge as our steel inner or liner of our double wall duct, and it's comprised of our single wall duct, 16 gauge steel, 18 gauge stainless. And that is suitable for use in New York City, but those are typically your code compliant gauges for the rest of North America. So that is the path forward for us. But if you're designing a black iron welded steel kitchen exhaust in New York City, you must adhere to these step up in gauges and have your specifications accordingly. Welding of your kitchen exhaust, it's pretty standard. I think you're very familiar with this, I'm sure. Continuous liquid tight, so we need to be able to hold the grease for everyday use, as well as the cleaning of the duct systems. And we also want our access doors to be leak-free or watertight. So the exception here, again, would be when listed to UL 1978. So Durasystems, we are listed to UL 1978 to eliminate the welding of the bolt of the connections. And in lieu of welding, we will bolt the connections. The rest of the duct itself, all joints in the duct, seams, penetrations are all fully welded. It's just the connections themselves. Sorry, one more person to invite in here. Great. And again, any questions along the way, please jump in and ask. So the separation of your grease duct. So now we're into section 506 3.5.1. We define their separations are not required. All interconnected hoods are within the same story. Interconnected hoods are within the same room. Do not penetrate fire-resistant assemblies. Do not serve solid fuel fire appliances. So what we are looking at doing here is talking about when you're connecting different hoods into a common system that runs through the building. So you can maintain your standard 18-inch clearances within the space, within one common area, one fire zone or fire separation, which is typically your kitchen space. From that point, once you penetrate rated assembly or that compartment, then you're going to need to protect that kitchen exhaust and have a 2-hour fire rating on that. So there's different methods of doing that. At Durasystems, I'll touch on some slides later. We do have the single wall and the double wall version of our Duraduct, and that will give you, the single wall will give you your 18-inch, and your double wall will be your 2-hour rated zero clearance. Now, in New York City, 99% of the time, right from the hoods, regardless of where we run, it's a 2-hour fire rated duct, zero clearance throughout the system. Once we get outside the building is when we look to use a single wall system. So that leads into our clearances. You can see on the top right-hand corner, this is a completed installed Duraduct KEX, which is a 2-hour zero clearance kitchen exhaust system. Your standard on your welded black iron is going to be 18-inch to combustibles, and 3-inch to non-combustible construction, which, depending on which city you're in, would include gypsum wallboard. Exception to this, if you're listed for reduced clearances with UL 1978, or if you're listed to uh, reduced clearance via ASTM E2336 would be zero clearance, so you can have combustible materials right up tight to the duct. And in New York City, you also have your option of your 2-inch calcium silicate block. Looking into the grease duct itself, post-installation, we do not waive any post-installation testing, so that should still be done. And in New York City, we have our smoke test under pressurized smoke test that's usually under being witnessed. So at Durasystems, we have no issues with a smoke test. In other jurisdictions, IMC talks about light testing. We've also been asked to do air or water pressure testing. All of the above are acceptable, any of the four methods. The smoke testing, you're going to follow New York City prescribed requirements. Outside of that, if you're going to do an IMC project, what we recommend is looking at ASHRAE 154, and that will give you options for your testing. But the IMC, the recent versions of IMC also talk about light testing. So any of those options are suitable for a Duraduct system. We're going to go into the testing requirements here for an ASTM 2336 product. Originally, when ASTM 2336 came out, a wall test was incorporated into that assembly, which at Durasystems we were mandated to run and pass. You can see that in the top. Since this recently, there's been some amendments to ASTM E2336, and they've now removed the wall test. The reason behind that is there's two competing standards. There's ASTM E2336 as well as your UL2221. The UL2221 did not have an E119 wall test where ASTM E2336 did. The reason behind ASTM E2336 incorporating the wall test was you're looking at that system to essentially, when you're looking at fire rating the system as it leaves the compartment, you want to be equal to shaft construction, which typically is the path of enclosing these materials, especially in a riser situation. So the wall test was imperative to prove that the system would perform in the same manner as a shaft assembly. So you can see it's very difficult to do. You take a four-sided duct, flatten it out into a wall, including the access door and joint sections, and you expose that to a shaft wall test. So for us, we were responsible of passing this test, which we did. From there, the other main fire test that you run is your internal, which is your center photo, and you'll see the flames coming out the top of the duct. So in this test, you're going to run a 4-hour soak at 500 degrees. So you're going to have the duct exposed to 500-degree temperature for 4 hours. And then at that point, it's a jet fire test for 30 minutes. And this really blasts the fire into the duct, trying to mimic a grease fire for an approximate duration of about the same amount of time that grease itself would burn out. One of the key here is obviously you have to make sure that the outer shell maintains that zero clearance. It does not get hot enough to ignite combustible materials. And the same prescribed requirements from an ASTM E119 wall test is applied to the external shell of the internal fire test. The other item that you have to watch for here is deflection. So they'll run a measuring device across the top of your duct. If your duct deflects more than 25%, then you also fail this test. So those are the two main requirements of the internal fire. So as you would in a grease duct situation, not only are you worried about the fire from the outside attacking the duct as it through the rest of the building, it's an internal fire that could start from the kitchen and run through the duct through the rest of the building. And you don't want to you want to contain the fire and not have combustible materials ignite through the rest of the building as you're running this duct system. Down at the bottom, you'll see the engulfment test and the hose stream. So this duct down in the bottom right-hand corner, this is post-test, post-hose stream. So this is after a 2-hour fire duration and a hose stream test. On the left, this is above the slab. The penetration you'll see as the elbow comes up through the slab. This is our fire stop detail. From that point, you'll also do surface burning, thermal transmission, non-combustibility tested, non-welded grease duct testing. These are leakage and material tests. They'll also certify and test the gasket and the insulating materials that used in the product. So there's about 12 to 13 tests in total that are required to get this listing. So it's very, very well vetted. So a zero clearance grease duct listed to ASTM E2336. This is NFP 96 compliant IMC IBC Canadian code also. SMACNA and ICCES AC 101. Now in New York City, it also is compliant as an alternate to your welded kitchen exhaust duct. The single wall version, this is your 18-inch clearance, meeting all of the same performance criteria in terms of the grease duct itself. And again, this is New York City compliant by way of the UL 1978 listing. Is there any questions so far on what we've covered? Moving through the next slides, we're going to just look at the Duraduct product real quickly. We have a UL 1978 liner, 16 gauge code compliant, and then the double wall version, which is called Model KEX, that is your ASTM E2336 zero clearance, 2-hour rated enclosure to the grease duct. Your access doors are built into the system and laid out to site requirements. The layout drawings will work with the contractor. We can also do this up front for an engineer. We can lay out the system. If you give us centerline dimensions, we'll lay it down into our shop standards. We can coordinate access door locations, making sure that we meet, New York City building code requirements. With the double wall version, you eliminate all requirements of any external wraps or enclosures. So this duct itself, the 2-hour rated Duraduct model KEX, can run exclusively through the building. All your fire stops are built into the listing of the product, and you can run that from your kitchen hood to the outside of the building, and you do not require any additional shafts or wraps on this duct. So you have a nice double wall metallic outer shell to complete the system. Custom fittings we are able to manufacture. If it's, if we have the ability to draw it properly and we have tight spaces to fit the system in, offsets, slopes, all of these items, we can do this with the system. We'll work with the designers, with the contractor installing to lay these out. So sometimes we have, more difficult looking systems where you're very tight on space. The nice thing about a double wall product like this, one, this is the only listed rectangular grease duct in the industry. And it gives you a very defined footprint. So you don't have to worry about the shaft wall being built around this. You don't have to worry about the multiple layers of wrap going on this and adding to the OD of the duct. When you look at the footprint of it, including the rods and the hanger system, you can actually define a space to hang this duct. The way the duct comes together are bolted connections. It's a double gasket. So you can see on the far right-hand side, we have the flange turned out, flat surface for the gasket to go on, the primary grease seal gasket, which is the red, and then we have a secondary gasket, which is a high temperature 2000-degree gasket. This goes on the exterior of the bolt hole on the angle iron structural flange. They come together, bolted together, and this will give you a grease seal under fire and everyday use. The supports that we utilize, going up the building vertically, it's going to have an option for a knee bracket or an angle support at the slab. So either option is available. The way that we do this, you'll see in the bottom pictures, we have a primary knee bracket support that gets welded to the duct and pre-insulated in the shop. From there, we have the bolt holes and the nuts welded in so that the contractor only has to work from the outside, bolting their knee bracket or their floor support into our duct, which will bottom out on the support, and then that will carry the weight of the duct. So typically, we'll carry the weight of the duct for every 2 floors and look for a support every other floor. And the fire stop for the slabs are again built into the listing of the product. Horizontally, it's pretty straightforward. Every 5 feet, you're going to have an angle and drop rods. The larger the duct, the larger the supports get. Our access doors, again, they're built into the duct. We will put the largest access door that we can on this duct. So typically you're going to stay minimum 1.5 inch top and bottom from the duct. It's a little bit different in the double wall because we also have the thickness of the double wall, so we have to add that in. So it's really the liner that we have to keep 1.5 inch top and bottom from. They're toolless access and reentry. So it's all wing nuts removable by hand, so very easy for the cleaners to work with. All of these access doors are built into our duct and pressure tested before they leave our shop. So when they get to site, you know that those access doors are sealed on tightly and they're ready for everyday use. Air movement, custom fittings, again, uh, if you have these very difficult fittings that are required to fit your space, we are able to build these, to manufacture these. We'll work with the contractor to lay these out in CAD, make sure they're going to fit the space. Radius throats, radius heel, square throat, square heel. We have the ability to manufacture this as a custom system. So sizing, aspect ratio, everything is going to be built to suit your product, nothing off the shelf that's sitting there waiting to be shipped. So everything we manufacture is a custom built solution. Getting into your design considerations for slope, NFP and ND6 talks about 2% slope up to 75 feet and an 8% slope over 75 feet. So this is a very, very, very different clause that's come in recently over time. New York City has also adopted this. So you're going to require grease reservoirs at your T's, but you also may need grease reservoirs in the midpoints of these systems. You have the washdown type sumps. We do not supply those, but depending on what jurisdiction you're in, the HJ may permit these to be utilized to reduce the slope. These are components we don't supply, but we can connect to, and we've done so in the past. But typically, what you'll see is a grease reservoir either at the midpoint, you can see on the right-hand side, or vertically on your T as you come down. Your drain section is nested within the double wall of this product. There's a spin-away cap clearly marked for the cleaners. They can take the drain off. They can extend the drain, clean the system, put it back the way they found it. We don't need them to do any work in addressing the fire rating of the system. So we don't want them cleaners on site after the fact having to manipulate the duct itself. So we've inset this drain into the system in the midpoint reservoirs or your vertical reservoirs. Design considerations for manifolding systems. So we have the largest listed kitchen exhaust in the industry. What that means is you can manifold or tie together the most hoods possible, having the largest listed duct system. So you can interconnect multiple hoods on the same floor. You can interconnect hoods on different levels as long as you have the fire rating, the extension of the fire rating, and your zero clearance installed. On the duct, which is the Duraduct KEX, we have the ability to really limit the amount of exhaust ducts running through your building, especially on the very large projects, it tends to be more where we are suited. Now our UL 223 and UL, or sorry, ASTM 2336, UL 1978 advantages. Again, it's the largest listed kitchen exhaust available. You have your zero clearance installations. We eliminate field welding. The leak-free joint design, so it's a bolted connection. All of the pieces are going to be pressure tested before they leave our shop. You're going to save space on the rectangular footprint by changing your aspect ratio. You can flatten the duct out. You have your inherent impact resistant protection and moisture resistance. The duct itself on the double wall is actually paintable. So you'll see here, this is an Italy project where the kitchen exhaust was exposed in the ceiling with those wood finishes, those wood drop ceilings. So they painted the kitchen exhaust there to match the ceiling color or the metal decking color. So you do have the ability to paint the duct, and it's a very easy inspection for listing compliance. Once you run your smoke test and you have your sign off, from that point, the only thing that needs to be vetted is your supporting method, and that's visually inspected every 5 feet, every other floor. It's a very easy inspection on that. Any questions on the kitchen exhaust? Comments? Okay, we will move into our review of the ASTM E119 code, which will tie us into our hazardous exhaust systems. So E119, this is your generalized acceptance criteria. No passage of of flames or hot gases. Your temperature rise on the unexposed side is limited to 140 average or a 180 individual. Assembly must remain in place and not collapse under design loads, and no through openings created through the test or the host stream. So the host stream is the pressure test done after, which is mimicking the firefighters coming in. So that's a 45 psi minimum pressure, and they spray the duct, the wall, whatever you're testing, as well as the fire stop. It all must stay intact with no openings. So your fire resistance rating, your fire test, your shaft assemblies, so to speak, within your building are all based on the ASTM E119 or your UL 263. But typically, most people are talking ASTM E119. Now, this is what dictates the construction, the fire rated encasement of a hazardous exhaust system. And so when we define the hazardous exhaust systems by New York City code, that's done in section 510. And typically what we're talking about here are laboratories or hazardous emissions. At times, you may have mists or dust in the ductwork, but mostly we're talking about our vapors, gases, fumes that we need to get from the space, from that hood, directly out of the building as quickly as possible. So the one item to really focus on here in a hazardous or laboratory exhaust setting is that unlike ventilation ducts where you can put fire smoke dampers in at your rated penetrations, you are not allowed to do this in a hazardous exhaust. So section 510 7.1 will prohibit the use of fire smoke dampers. So in this instance, for a hazardous exhaust system, it's fairly similar to a kitchen exhaust where you're not just worried about the fire from the outside like you might in a stair pressurization system. You're worried about the fire internally and externally. And that's because you don't have fire smoke dampers to blank off that system from having the fire, the heat run inside that duct through the other compartments of your building as you're trying to get out. So from this standpoint, you need to have your duct tested internally as well as externally. So section 510.7, we'll talk about your hazardous exhaust systems. We're also talking about floor ceiling assemblies, penetrations, very similar again to a kitchen exhaust system, but with a different internal conveying item. The duct shall be construction materials compatible with the exhaust as per section 510.9. So you will have a construction chart depending on the size of the duct. Typically, what we're really focused on here is what are we exhausting and what type of corrosion resistance do we require. So Durasystems, we will have 304, 316 exhaust options for our hazardous or laboratory exhaust. We have a specialty gasket that has been tested and vetted for hundreds and hundreds of different chemical exposure. We have a data sheet on that, that if you require, we can get that to you. Um, and so that's really the key here in terms of designing the duct system. So making sure that they're compatible with Section 510.9, and then our supporting systems, Section 510.10, talks about that. Now, this is your duct being supported, assuming that your fire resistance rating or your fire shaft is external to that duct and its supports. At Durasystems, when we build the duct into the rating assembly, your supports are then designed into the listing also, giving you that assurance that the duct is supported under fire load, where as opposed if you had a welded system, stainless welded duct supporting every 10 feet, you have to watch what you're protecting it with because that protection may require additional supports to ensure that the fire resistance rating or the fire protection product stays in place under the 2 hour duration. Model LXD, this is Durasystems product for single wall exhaust, chemically inert liquid and liquid tight gasket sealing system. So that's called our CRG gasket. And this goes in between, sandwiched between the flanges. In this system, the LXD, we're actually able to build this round or rectangular. And what you see quite often, you're going to see the larger mains being constructed rectangular or square, and then your taps off of that coming in, back to the hoods or to the fans as round. So we have the ability to construct both. Here you can see these smaller fan units with all squared around connections that we've built. And this is a large hospital that was built not too long ago. Um, the testing that we've done, again, mimicking what we try to see here on an everyday basis with the large rectangular main, and then your smaller round taps coming off of that. We've done leakage and deflection testing to ASHRAE ANSI 126 2000 to plus or minus 10 inches. We've taken it one step further and we've run pressure decay testing, which is a very difficult test to pass at 8 inches positive and negative. So to catalog an 8 inch positive negative pressure decay, you actually have to run the test at 10 inches to catalog the 8 inch. Features again on this system. So you have your round or square bolted connection. We have our proprietary gasketing system. We have a chemical resistance chart for the model CRG gasket, as I mentioned. This can be provided to you at any time. We have a chemically inert and liquid tight gasketing sealing system, which is the CRG, the patented flange design, chemical resistance chart. We also have the ability to eliminate all of your welding, stainless welding in the building, and we factory pressure test all our welds prior to shipping. We are the only manufacturer that has a code compliance research report for a double wall hazardous fire rated duct system. So this is unique to the industry. It is based on the IMC. It can be referred back to the New York City Building Code as the clauses are very closely matched in this aspect of hazardous or laboratory exhaust. It is listed to ASTM E119. Your penetrations are listed to ASTM E18, E814. You have internal and external fire exposures. Your duct meets the requirements of Section 10, which is the same as Section 10 fire or 510.7 of the New York City Building Code. And it will have an accompaniment of a code compliance research report along with the listing for that product. It's unique to this industry. Seam welders, we have multiple seam welders. So this is what we will utilize for our straight section. So the duct comes off a coil line, broken into rectangular shape, and then run through seam welder. We have the seam welder for the round and for rectangular systems. And this ensures that the duct is manufactured square, without twists, and very, very, very economically built in our shop. and which is the reason why contractors are pushing to utilize our product. It's a cost-effective solution and saves a lot of time and effort on space, or sorry, on site. A very large portion of each project is HVAC related in terms of laboratory exhaust. Over 20.2% is HVAC. Now, the laboratory exhaust is a big part of this. What happens with a welded system, if you are doing a retrofit, you're going to have to cut out that welded system and essentially scrap that. With our bolted connection, if you're reworking a space, a lot of times you'll see, especially the taps into the main, are going to be the same diameter pipe. You have the ability to pull that product down, put it into storage during the demolition phase, get some new gasket from the manufacturer, and put that duct back into place. That will save money that can be spent on other capital costs in the building. This is something that schools, university, publicly funded projects, they will see the value in this. And we've presented many times directly to universities, hospitals, and you will see a project that has $500,000 worth of new kitchen exhaust in a retrofitted lab, which means you're throwing away $500,000 worth of product that was welded and installed 5, 10, 15 years ago that all needs to be scrapped. So there is potential for real life savings by utilizing a bolted connection system. And very similar to the welded kitchen exhaust, the same factors of eliminating your welding. These are things that contractors deal with quite often. Temporary power costs can add up. If you are especially in a retrofit space and you have to power up to weld the ductwork, that is a huge cost that can be eliminated. Not having the correct power, running out of materials to do the welding, daily hot work permits, fire watch, all of these items are eliminated by utilizing a bolted connection like Duraduct. Does anyone have any questions on hazardous exhaust or laboratory exhaust? Okay, we'll keep moving forward. So now we're into our fire resistant duct system. This is our ventilation duct systems. So one of the systems that have been used predominantly in the past to obtain a UL listing is a standard called ISO 6944, where you're going to put the duct into the furnace, penetrate a wall, come out of the non-fire side, and have that system ducted and exposed to a time temperature curve very similar in nature to ASTM E119. So this is the path or one of the paths forward for ventilation fire rated duct. Now, New York City Building Department have OTCR building bulletins out on the requirements to satisfy fire resistance rating and fire resistance rated duct supply in New York City within the 5 borough. When you're using an ISO 6944 listed product, it must be measured and observed to enable the criteria of stability, integrity, and insulation. If you are looking at an ISO 6944 listed product, there are listings that separate these 3 items. You only gain a fire resistance rating if you have satisfied the same duration of time, the hourly rating of all 3 of these criterias. Is very important to know this because there are products in existence that only satisfy 2 of the 3. There are systems that will give you a 2-hour stability, a 2-hour integrity, and a 0 insulation rating. These systems do not offer you a 2-hour fire resistance rating. They offer you a 0 fire resistance rating. The lowest of the 3 criteria, the stability, integrity, insulation, the shortest duration of the past component of that test is your hourly rating. So it's very important to know this. It's very important to have the New York City Building Department building bulletin at your fingertips when you're reviewing fire resistance rated ventilation duct systems. There are different marks and category codes, and we need to be aware of this when we're looking at products. There are listings that will give you fire protection rating, and there are listings that give you a fire resistance rating. When we are looking to utilize a ventilation fire resistant duct, we are utilizing that duct to eliminate a fire resistance rated shaft, an ASTM E119 shaft. And most of the time in New York City, you are looking at utilizing that as a crossover duct between shafts. So a duct coming out of a shaft, crossing over on a floor, entering another shaft, and going up through the building. This is a classic use of a ventilation fire resistance rated duct in New York City. So because we are trying to substitute for a fire resistant rated shaft, we need the duct to provide a fire resistance rating equal to that shaft, which is typically a 2-hour rating. We cannot utilize a product that gives us a fire protection rating because you're not attempting to give the duct going from shaft to shaft a fire protection rating. We are trying to give that duct crossing over a fire resistance rating. So those two words, if you take the time to go and read through code, you will see a defined difference between those two items. So there are different product category codes, and these two category codes will define this. They will talk about the hourly ratings apply only to complete assemblies. So if you have a duct that gives you a 2-hour fire resistance rating, and that duct requires a ventilation duct of whatever construction the listing has, and some sort of external wrap or enclosure, you must have both of those products together to give you the fire resistance rating. There are listings for only one component at times of those two components required to get the fire resistance rating. The one component only may only offer a fire protection rating. So we have to be very careful and understand the difference between the two. The UL category codes will walk you through these differences. Again, the OTCR building bulletin talks about the utilization of the building, of the different category codes to meet the building requirements. The HNLN, if you're looking at UL, this is the category that you can utilize to satisfy that OTCR building bulletin 2105-013. This is the difference between those systems. You will see fire resistance rating. This is an HNLJ category code. Ventilation duct assemblies, fire resistant rating, giving you the hourly duration. You will see above an uninsulated or a fire protection rated product, giving you a 2-hour stability integrity, a 0 insulation rating. This duct, when pulled into a fire resistance rating category code, will offer you a 0 hourly fire resistance rating. It's very important to know the two because you're not equaling the protection that you are attempting to equal with that shaft construction. This is the building bulletin. There is an updated version of this. Actually, this might be the updated version. But 2018-013 is your building bulletin for ventilation fire rated assemblies. Please ensure that you are looking at the correct version. Some of the different evaluation criteria, again, your ISO 694, your ASTM E814. So that is to define the fire resistance rating of the duct as well as the penetration assemblies for that system. There are size limitations for the duct. There are size limitations for the fire stop. These also must be adhered to. You'll find this in conditions of acceptance, section B. Again, there's the other note here, the stability, integrity, insulation shall be equal or greater to the hourly rating required. This is pulled from the conditions of acceptance out of the OTCR building bulletin. One of the other notes within the building bulletin It's excluding systems from section 50210, 504, 5063, 510, 511. Some of these are dryer exhaust. Some of these are product conveying duct systems. So your hazardous, your laboratory. So ISO 6944 is not an acceptable solution for the ducts under these IMC sections, or sorry, these New York City Mechanical Code sections. So ducts shall not be accepted as alternate to code required shaft enclosures. The other item you cannot utilize an ISO 6944 duct for is your vertical shaft. You still must manufacture that in accordance with the building code, block, brick, gypsum, etc. The one item that it does talk about shall not be an accepted to code required or prescribed shaft enclosures. Code requires ASTM E119, and that is your listed assembly within section 703.2. Duraduct now has ASTM E119 listed assemblies. These assemblies can move vertically through buildings in New York City. It meets the requirement of the building code. We now have vertical ASTM E119 duct assemblies listed with subducts, listed with fire and smoke dampers that you can tap off on each floor. This is the only product in the industry that is listed to ASTM E119 and tested in the manner of use. So it's a very difficult test to pass. We also do not believe any other manufacturer have fire dampers tested with their system, as well as subducts tested into their system. So this puts you one step ahead when you're looking at eliminating space or saving space with the Duraduct product. So Duraduct GNX is this solution for ventilation exhaust systems. The very first product that we started with at Durasystems was the Duraduct HP. This utilized a product called Durasteel. Hopefully some of you are familiar with the Durasteel. We've used this on commercial and industrial products many, many times over in New York City. It's going to give you impact, fire, and blast resistance on the duct. The Duraduct GNX. This is a lighter wall system. This is our ASTM E119 listed 2-hour fire resistant double wall duct. You get an R value within this duct of 4.5, which should satisfy most air movement requirements. So you don't require any additional wraps or enclosures, not just for the fire resistance rating, but also thermally in the system. We do have one other option. It's called Duraduct GNX R6. And the reason behind that is you get an R value, an increased R value of R6 on that product. The fire smoke dampers, as long as you're utilizing a UL 555 fire smoke damper, this can be built into the duct. So as we tap off the duct on floors, we have sleeves that are built in to accept the damper. That can be done in our shop or in the field. The subducts also, these are built into the duct in our shop, and these are tested and listed as an assembly with subducts. Now, the reason that we utilize a GNX R6 on this, which is a slightly thicker wall than the GNX, is what we found out during the R&D of adding a subduct into our fire rated ventilation duct is you have in a ventilation duct, you're closed off to the environment. You're talking about a stair pressurization or you're crossing over from shaft to shaft. It's a closed duct. In the instance of a subduct, you now are introducing fire into the duct system. So it's a different aspect altogether. Mind you, it's a much smaller opening and you're not adding the same amount of heat as you would as hazardous or laboratory exhaust. But nevertheless, we found out through R&D that it definitely performs in a different aspect. So we've gone with a thicker wall now on any time you utilize a subduct into this. So we've done this a lot on dormitories, things of that nature, where you're tying in a lot of washroom exhaust into a common vented riser. and we can run our Duraduct GNX up the building, tap off at each floor, and you can tie into that. The subduct stubs out where this standard SMACNA ductwork can come into, and then you eliminate all your fire dampers on every floor utilizing the subduct system. Engineering evaluations. When you exceed the listing sizes of the ventilation duct manufacturer, the fire rated ventilation duct manufacturer, um, you are going to be required to do an engineering evaluation judgment. This is the IFC, the International Fire Stopping Council. We are members. It's one of the largest fire stopping groups in the world, associations in the world. It's a global association. And they have given jurisdictional assistance in things such as writing engineer evaluation judgment. They run seminars on fire stopping, compliance, and inspection. But from our perspective, we look at when you need a duct larger than that can physically be tested in the furnaces that we have in North America. And one of the first items is not to be used in lieu of tested systems where available. So you're not going to go and take a duct that's listed to 24 by 24 and try to write an evaluation for that to get, to 10 foot by 3 foot deep when you have a duct that's listed to 96 inches wide and 24 inches deep, and it's a smaller jump to get to that evaluation judgment. And at Durasystems, whether it's hazardous, kitchen, or ventilation duct, we have the largest listings in the industry across all of those products. So really, we're giving you the most flexibility to move as much air as possible, exhaust as much air as possible in a listed assembly. The fire stop also, if you recall back when we talked about the OTCR building bulletin, you also must comply to the listed size of the duct as well as the fire stop. At Durasystems, we hold the largest duct penetration fire stop in the industry. It's 66 square foot opening. Very, very large, larger than you're going to often need. So mechanical protection is built into the system. IMC section 603.15 specifically talks about this, especially with the life safety system. We're going to have an impact resistance built into that duct based on the metallic exterior, and that takes us right from ventilation through exhaust through kitchen. The blast resistance, so this is something we did quite often at the new towers that were built not too long ago. In all the common areas, there was an overpressure requirement for all the ductwork exposed in the public areas. At Durasystems, we've done extensive blast testing. This is with a company called SWRI that does all of the U.S. military testing down in Texas. I was actually able to witness this test myself. It is quite the overpressure. So it's 9 pounds of C4, and then the distance to the duct is what defines the overpressure. This was exposed to multiple overpressures. So this duct passes at 27 psi or 2 bar overpressure 3 times. It was exposed, the same duct 3 times exposed to that overpressure. So very tried and tested product if you need a blast or blast and fire resistant product. Fire rated advantages, again, very similar to the other products, although in this situation, you're not typically welding your duct that you would enclose in drywall. So very similar connection style, though, to what sheet metal contractors are used to. You have your TDF or TDC style connection. The duct is all built, pressure tested, and sealed in our shop prior to being shipped to site. Any questions on the ventilation fire rated duct systems? Okay, we'll keep moving along here. So this is something new that we have been designing. I'm going to preface the discussion here on this. First of all, this project is stalled currently due to the high demand at the OTCR. We have this product vetted through the OTCR, the building department, and the fire department We have a draft OTCR in place that's approved by DOB and Fire Department, FDNY. COVID happened. The gentleman that was working on this project, Sion, retired. Um, right now, there is a huge logjam, so I'm told, of projects that are looking to be finalized, and we, as of yet, still do not have final approval on this product in terms of a live building bulletin. But we do have some solutions to offer, and this is in terms of fuel oil line enclosures. So, fuel line enclosures in New York City have two different prescriptive requirements. Essentially, you have your prescriptive requirement for vertical, and you have a requirement for horizontal. Horizontal systems are based on an E119 listed enclosure. So that can be block, brick, drywall. It can also be Durasystems Duraduct 2HR, which is a 2-hour ASTM E119 enclosure system. This system can be utilized to enclose your fuel line enclosure, or sorry, your fuel line pipes, typically your pipe and pipe. It can be three-sided or four-sided, and this can be used horizontally in the building to enclose your enclose your fuel line pipes. The use of the materials are going to be deemed through Section 28, 113.2.1. Materials specifically prescribed by this code or department, rules may be used as prescribed without prior approval of the commissioner. This was given to us by the New York City Building Department in terms of the horizontal product, that we are able to utilize this as we speak. Now, vertically is a different story. Now, vertically, you're going to have your prescribed requirements for your vertical masonry or brick chase. We did all of the work to prove equivalency to that. We do have the DOB signed off on that, as well as the fire department in New York City. But again, it is not live. So right now, as we speak, we can enclose fuel oil lines horizontally, but we are staying away from vertically until the product building bulletin is live. Some other products and solutions, we have our thermal panels. These are great for outside fresh air type plenums. It's a double wall metal panel. There's no through metal, so you're going to get an actual R value per inch, 4.5. We have our panels. They come in 2.5, 3, 4, 5, 6 inches thick. Depending on the size of the plenum, this is a 30-foot high plenum. So we did need some supplementary steel, but depending on the height of the plenum, you typically don't need much of a skeleton to install it. We can design this to handle different pressures. Right now, we're supplying this at JFK Airport, and kind of during the supply of this, we were asked to review the product to a 10-inch overpressure negative. So this went through and also required engineering stamp. So we got a New York City engineering stamp and vetted through the supports that would be required to support the system under that static pressure. So we really will work with you as need. This is a nice, easy, cost-effective solution for plenums that are required to be thermally rated. We also have the product very similar that is for a 2-hour rating. So this is a separation. This is a photo being utilized in a generator room as your separation, 2-hour separation. We can separate shafts. We can build plenum walls, enclosures. 2-hour rating. This is a product called DuraWall. And that kind of gets us to the end of the seminar. We didn't get too many questions along the way, which usually chews up a little bit more time during this presentation. So I'll leave it open right now. If there are any questions or comments, If not, I can hand this back over to David.
Yes, I have a question.
Sure.
Hi, my name is Gaetano, and I work for Nortec Air Solutions. We build custom air handlers. My question is often enough I get asked the question, can a fire smoke damper be installed on the sheet metal of an air handler or on the opening of an air handler? We do smoke dampers quite often, but not fire and smoke. I'm under the impression that fire and smoke can only be installed on a fire rated duct, or external to the air handler on or in a fire rated duct. Can you comment on that?
Well, yes and no. So that's really more of a question for fire damper manufacturers. There are what they call out-of-wall type dampers that certain manufacturers have, and that can be utilized. 99% of the time, a fire damper is going to be installed at the wall, at the floor. When it's utilized in the duct, it's typically done so because of having access to the fire damper. Something like our system here, where we talk about our ventilation duct system that can tee off with a damper, we're doing that as we are attempting to be a shaft alternative, and kind of um, uh, you know trying to be an innovative solution that doesn't exist in the market. And we had to go and test that on ourselves with different fire damper manufacturers, all tested to the UL 555 rating. So it's going to be tough for me to give you a solid answer on that. You know, I don't know as air handler manufacturer that you can just sign off on that damper being there unless you could work with one of the manufacturers with an out of wall type damper that maybe you could closely mimic their listing documentation and maybe get some sort of evaluation to be able to do so. I hope that helps, but
It does.
we don't manufacture dampers, but someone like we worked closely with Naylor and some of the projects that we've done. Um, so that the product that I mentioned before, the DuraWall product, it's an ASTM E119 listed shaft assembly, but we had and fire dampers are listed to go in shaft wall assemblies. But we had an inspector on a very large project say, well, I don't see the tie I want to see because whenever, especially if you're a custom air handling unit manufacturer, an HJ, an inspector sees something that's different, especially the first time around, you should be expecting to get some questions. And if you cross your T and dot your I's, our experience is they'll understand that you're attempting to be innovative, that you have done the testing, that you have done the homework. So, maybe a company like Naylor or a Ruskin, someone that's reputable, that has an out-of-wall type damper, might be someone you could work with, to kind of achieve that. The other thing that can be done is, because we do have the damper listed in our system, you might come off the unit, and somewhere between the unit and the wall, you could incorporate, a fire damper inside of our duct system, as an extension. But again, it's an outside of the box solution for sure.
Okay, thank you.
If there's no other questions, David, do you want to
Sure.
back
Yep.
in?
I appreciate everybody joining, and if you have any questions, you can always follow up with Gerry or myself afterward, and we will be taking care of these certificates shortly, and you should see those within the next week or two. So appreciate everybody joining, and have a great day, and thank you, Gerry.